Ever wondered how those massive bridges we drive on every day are built? Today, we're diving into the world of modern bridge-making technology with the incredible Bridge Girder Erection Machine, also known as the SLJ 900. Get ready to be amazed by this engineering marvel. Today we're talking about a machine that looks like it's straight out of a sci-fi movie. The SLJ 900 is a gigantic, 580-ton beast designed to make bridge construction faster, safer, and a whole lot cooler. Traditionally, building bridges involves a lot of heavy lifting, cranes, and sometimes even closing roads. It's slow, complicated, and let's be honest, a bit boring. But with the SLJ 900, it's like watching a giant transformer at work. This beast moves entire bridge girders into place with pinpoint accuracy. It's so efficient, it makes you wonder why anyone ever did it the old-fashioned way. Let's break down how this mechanical marvel works. First, it's got these massive legs that straddle the bridge pillars. It then uses hydraulic systems to lift and place the bridge girders precisely where they need to go. Imagine playing with Lego blocks, but each block weighs as much as a blue whale. Picture this. You've got your bridge pillars all set up. The SLJ 900 rolls in like it owns the place. It picks up a girder, slides it over the pillars, and then gently places it down. Boom! One piece of your bridge is done. Rinse and repeat, and before you know it, you've got a fully formed bridge. The SLJ 900 isn't just big and strong. It's smart too. It's equipped with advanced sensors and GPS technology to ensure every girder is placed perfectly. This reduces errors and increases safety on the construction site. Safety, efficiency, and sheer awesomeness. The SLJ 900 has it all. This machine is revolutionizing the way we build bridges, and it's a testament to how far engineering has come. It's like watching a giant mechanical spider weave its web across the landscape. And when the job's done, the SLJ 900 packs up and moves on to the next project. It's like a superhero swooping in, saving the day, and then heading off to the next adventure. Let's talk specs for a minute. The SLJ 900 is 91 meters long, 7.4 meters wide, and 9 meters tall. It can travel at a speed of 8 meters per minute when empty and 5 meters per minute when carrying a girder. It's designed to handle girders that are up to 900 tons and 50 meters long. Impressive, right? This machine has been used to build some of the most iconic bridges around the world. From China to Malaysia, the SLJ 900 is leaving its mark on the landscape, one girder at a time. So, the next time you're driving over a bridge, take a moment to appreciate the incredible technology that made it possible. And if you see a massive machine that looks like it's about to transform, don't worry, it's just the SLJ 900 doing its thing. Arch bridge, a structure that combines elegance, strength, and engineering ingenuity. An arch bridge is a timeless architectural design that has been used for thousands of years. Its key components include the arch itself, the abutments at each end, the keystone at the top center of the arch, and the deck that carries the load. First, the construction site is prepared. This involves surveying the area, ensuring stable ground conditions, and clearing any obstacles. Accurate measurements are crucial for the bridge's stability and alignment. Next, deep foundations are laid to support the abutments, which will bear the weight of the entire structure. These abutments are constructed using reinforced concrete, ensuring they can withstand immense pressure. Temporary supports, known as centering, are erected to hold the arch in place during construction. The arch is then constructed from the abutments towards the center, using carefully shaped stones or precast concrete blocks. The keystone is placed last, locking the arch into position. Once the arch is complete, the centering is carefully removed. The arch's unique design allows it to distribute weight evenly across the structure, providing incredible strength and stability. Arch bridges are renowned for their durability and aesthetic appeal. They are often built in locations with natural valleys or rivers, where the terrain supports the arch design. You'll find them in both urban and rural settings, providing vital connections and enhancing landscapes. Beam bridges is one of the simplest yet most vital types of bridges that connect communities and facilitate travel around the world. A beam bridge, also known as a girder bridge, is straightforward in design but highly effective. It consists of horizontal beams supported by piers and abutments. Let's break down the construction process step by step. Engineers assess the site, considering factors such as span length, load requirements, and environmental conditions. Detailed blueprints are created to guide the construction process. With plans in hand, the construction site is prepared. This involves clearing the area, excavating for foundations, and setting up necessary equipment. Ensuring a stable foundation is crucial for the bridge's integrity. Next, piers and abutments are constructed. These vertical supports are typically made of reinforced concrete, providing stability and bearing the weight of the bridge. Piers are placed at intervals along the span, while abutments are positioned at each end. The beams are then placed atop the piers and abutments. Depending on the bridge's size and purpose, these beams can be made of steel or precast concrete. Cranes are often used to lift and position the beams precisely. With the beams in place, the deck is constructed. This surface will carry traffic and can be made from concrete or other materials. Workers install rebar for reinforcement before pouring and curing the concrete deck. Finally, finishing touches are added. This includes installing guardrails, lighting, and road markings to ensure safety and functionality. At this stage, the bridge is inspected thoroughly to meet all safety standards. Beam bridges are widely used due to their simplicity and cost-effectiveness. They are ideal for short to medium spans and are commonly found in both urban and rural settings, crossing highways, rivers, and railways. Compared to other bridge types, beam bridges offer several advantages. They are relatively easy and quick to construct, often requiring less complex engineering and fewer materials. This makes them a cost-effective choice for many projects. Additionally, their straightforward design means they are easier to maintain and repair. When considering factors such as construction time, cost, and maintenance, beam bridges often come out on top for projects requiring efficient and economical solutions. Beam bridges are not just about efficiency. They also play a crucial role in enhancing connectivity and accessibility, supporting both vehicular and pedestrian traffic. Their versatility makes them a staple in modern infrastructure.